Hey everybody, in today's lesson we're going to be learning about the key features of quadratic functions. I'm going to go ahead and tell you what your assignment is because you're going to be doing your assignment today through the video. There are several vocabulary words or terms that you need to be familiar with dealing with quadratic functions, and I simply want you to write down the definition for those terms and then write them in your notebook and then take a picture of them and turn those in to me for your grade for today. The first feature of a quadratic function is the x-intercept, which we all know the x-intercept is the point where a graph crosses the x-axis. Now, in a quadratic function, of course, your graph is in the shape of a parabola. If you have forgotten what a parabola looks like, if you were look at the green graphs here, the parabola is either the hill shape or the U shape. That's what a parabola looks like. So when you have an x-intercept on a quadratic function, that's just the point where the parabola crosses the x-axis. And if you notice in these two graphs, you will have two different x-intercepts because each of those parabolas cross the x-axis in two different places. Of course, the y-intercept is the point where the parabola will touch the y-axis. And if you notice in each one of these, your graph only touches the y-axis at one point. So that would be your y-intercept. The vertex is either highest point of the parabola or the lowest point. If it's the highest point of the parabola, of course, it's going to be called the maximum. If it's the lowest point of the parabola, it's going to be called the minimum. So just remember the vertex is either the highest point or the lowest point of your graph, the maximum or the minimum. You probably need to pause the video now so that you can get these definitions down in your notebook. The next feature of a quadratic function is called the point of extremum. It's the point at which the value of a parabola is the largest or the smallest. So this is the maximum or the minimum, which if you think about it, the maximum is the vertex and the minimum is the vertex, just depending on whether your graph opens upward or downward. So your point of extremum is your vertex. Just a fancy term for vertex. Number 5, the axis of symmetry is a vertical line that divides the parabola into two congruent halves. It always passes through the vertex of the parabola. So the axis of symmetry just cuts your parabola exactly in half. It goes right through the middle of your vertex. The root or roots, we say roots in this case because we know that a parabola, we said, has two x-intercepts. So the roots are also the x-intercepts. You see here with a lot of these features, we have several different names for the same feature. The next term, number 7, is the solution or solutions, which are the roots of the parabola. Well, we just said in the previous definition that the roots are the x-intercepts. So you see here that the x-intercept is the same thing as the roots, which is the same thing as the solutions of the parabola. Number 8, the zeros are the x-intercepts of the parabola. So I hope you're seeing this pattern here. The x-intercepts are also called the roots, which are also called the solutions, which are also called the zeros. So whatever your x-intercepts of a parabola are, those will also be your roots. Those will also be your solutions. Those will also be called what is called the zeros of the function. The domain of a parabola is going to simply always be all real numbers, because if you remember, the domain is all of the x values. And if you think about how a parabola either opens upward or downward, you can see how all real numbers would be part of the domain. The range is a little bit more complicated in the domain. If the graph opens up, then the range is the vertex or the minimum value, and all numbers greater than the minimum. If the graph opens down, then the range is the vertex, which is the maximum value, and all the numbers less than the maximum. And I've given you two graphs here to show you. In the first one, the one that opens down, you see where the y-intercept or the maximum is at 2. That's where it crosses the y-axis, is at positive 2. So the range would be positive 2 and all the numbers less than positive 2. So we say the range is less than or equal to 2. In the second graph, you see that the minimum, which is the vertex, is at negative 2. That's where it crosses the y-axis. So you see that the range would be negative 2 and all the numbers greater. So for the second one, the one that opens upward, we say that the range is greater than or equal to negative 2. So once again, all your assignment for today is to copy those 10, I think it was, terms. Yes, 10 terms down into your notebook, take a picture of them, and then send that to me for your assignment. Our next assignment on the next day, you will be using these definitions to do another assignment. See you next time.